This is a mini ITX rack mount enclosure from MyElectronics, and this is the Turing Pi 2, a 4-node Raspberry Pi cluster board. In this video, I'm celebrating 250,000 subscribers by racking up the Pi cluster. Now, why would I want to rack mount it? Well, a few reasons. First, it's no good running a server on my desk completely unprotected and likely to get swiped by Redshirt Jeff. Second, I have a network rack, so might as well use it. And third, I want to do some fun things with the Turing Pi next year, and the first step is to get it mounted more permanently. So let's take a look at this enclosure. A couple months ago, I asked if anyone knew a good 2U enclosure for mini ITX boards. There are a lot of 1U ITX enclosures, but unfortunately the Turing Pi 2 is just tall enough it wouldn't fit. MyElectronics reached out and told me they had a spare 2U ITX rack enclosure and would love for me to use it, no strings attached. So thanks to them, I have this shiny black and blue enclosure. This case was actually custom designed for someone else, and so they don't list it on their site, but they told me if enough people are interested, they might tweak the design and produce a model specifically for boards like the Turing Pi 2. So maybe send them an email or tweet if you're interested. The number of screws required to pop off the top is a little annoying, but once inside, it's a nice roomy box. It has two front panel USB 3 plugs, a front panel power switch, and it came with a 180 watt flex ATX power supply, this FSP 180. That should be plenty to power the Turing Pi and anything I want to run on it. I installed a Noctua 80mm fan in the back, and it has mounting points for a mini ITX motherboard and up to 5 SATA SSDs. One thing that a lot of people have asked about on previous builds is an I/O shield. So the Turing Pi 1 never came with an official I/O shield, and the Seabear that I talked about didn't have one either. But the Turing Pi 2, I asked, do you have an I/O shield for it? They said, not yet. So I went ahead and designed this little one. But I put this up on Thingiverse in case you buy a Turing Pi 2 and want one of your own. So the great thing about standards is that this is mini ITX, and Turing Pi never actually talked to MyElectronics, but because they use the standard that's mini ITX, this mini ITX case works perfectly with this mini ITX board. So when I put this board in, the standoffs are already in the right space, the I/O shield is in the right place, and all I have to do is screw the board in, and I have this Raspberry Pi cluster inside the case, just like any other PC build that uses mini ITX. So MyElectronics includes all the parts that I needed to install up to 5 SATA drives. I don't need to do that for this build. I just have these 2 crucial drives that I'll be putting in, but they have all these screws. All these screws are Torx T10. So this case has a little bit of a weird way of mounting SSDs. I have 2 crucial MX500 SSDs. These are SATA 3. They're a little bit of overkill for this build, but for the things that I'm going to do with it, I will need some storage space, and I'm going to put these 2 terabyte drives into RAID 1, so I'll have 2 total terabytes of storage space, but 4 terabytes in the build. And I'm going to share these across the cluster using NFS. The way that these SSDs are going to mount up to this case is a little bit strange. It has these holes over here on the side, and the easiest way I've found to do it is to stick these screws in through the holes. So stick a screw there, and stick a screw here. And I'm going to put the SSD up against here and screw them in. As you can see, it's not the most efficient way of mounting these things, but it fits well in the case. I think if they were going to mass market this case, I would rather see some hot swap trays. Okay, those 2 are in. Let me set this back down. Alright, so the drives are in, and I'm going to connect it up to the board. So the 2 slots are here, SATA 1 and SATA 2, and MyElectronics sent me these 2 SATA cables. You can use any that you want. I like these because they're black. I actually asked, does the case come in black? But this was the one that they had, and it's blue. It still looks nice, but as Batman once said, does it come in black? This case comes with a 180 watt power supply. I think that should be enough juice for pretty much anything we'd want to run on a Turing Pi. If you're going to run more high-powered PCI devices, you'd need a better power supply than that, but I think we'll be fine here. I don't think I'll need any of those, but I will need board power. So I'm going to plug this into 24-pin connector right here. There we go. And then we got our two SATA power connectors here. There we go. So we got power connected. The fan, as I mentioned in my previous video, the fan header on this board with the firmware that I have right now does not actually turn on the fan header. So when it does, I can just plug it in like this and I'll have the fan with full PWM control. But for now, I actually have an adapter since that connector's not working. Probably by the end of this video, the firmware might be updated. I know that they're working on that right now. But for now, I'm just going to plug this into the 12-volt supply using this adapter from StarTech. So the fan will just run full blast for now. So next up, I have USB 3. So this case actually has two USB 3.0 ports on the front. And the Turing Pi 2 has that USB 3 front panel header, which is connected to node 4, which is this bottom slot. So this board has two USB 3.0 ports on the back, and those are connected to here, and two USB 3.0 ports on the front. So I'm going to plug this header in. Let's route this somewhat intelligently. There we go. The next connections are the front panel power button and LED, and the Turing Pi 2 has a front panel header, but again, the firmware is a little bit delayed, so right now I'm going to plug it into the JTAG header on the back, where these signals are actually connected to right now, and then once I get the new firmware, I'll be switching them to the front panel header connectors. There are also a few PCI Express slots, at least cutouts, for where they would be if you had a mini ITX board with a PCI Express slot over here, and then a header that would put them 90 degrees. This board doesn't have that. This board has mini PCI 2 slots, and then the other two Pis or NVIDIA Jetsons will have their own things. So there's USB 3.0, and this other one has SATA built in, which will power these two drives on node 3. So I'm not going to use those right now. I actually have a couple blanks in the mail coming to me. But let's put the lid on this thing. And we'll get all the screws in. One thing I would like to see, so if MyElectronics is watching this video, or if you're asking MyElectronics to make a case like this for you, it would be nice to have a panel on the top that just comes off, maybe with a couple screws on it. But this one goes around the sides, and there's 4 screws on the side, 4 screws on the top. That's a lot of screws to get out just to get access to the top if you're doing something like swapping a Pi out or swapping an SSD. The other thing that would be nice is having better thermal management so that the fans can pull air across the board. I know that for a lot of PC builds, the motherboard would have its own CPU fan, but for a Raspberry Pi board, that's not really a thing, at least not yet. All right, and let's stick this over here and plug it in and see what happens. So I'm going to put this on. So this power supply doesn't actually have a power switch, so I have to rely on the power button, which is fine. I mean, that's how you usually manage servers. But it would be nice to have an extra power switch on the supply itself, but that's just not the case for these slim power supplies. With power connected, I have to wait a few seconds for the Turing Pi's MCU to boot. Then I can press the power switch, and the cluster starts booting up one node at a time. Now, my main goal today is to make sure I can turn on the cluster and have everything work when it's screwed into my rack. The last thing I want to have to do is pull it back out to reseat a cable inside. So I know the power button works, which is good, but now I want to make sure the Pi can see all the peripherals, like the 2 SSDs on node 3 and the front and rear USB 3.0 ports on node 4. So first, I'll log into node 3 with SSH. I can use the lsblk command to make sure the 2 drives are showing up, and there they are, SDA and SDB. And to make sure they're correctly identified as crucial MX500s, I'll run sudo fdisk-l. And there they are, the last 2 drives, 1.82 terabytes each. Later on I'll put them in RAID, but for now I'm happy they're working, so I'll switch to node 4 to test for the USB 3.0 ports. If I run LSUSB, I can see everything that's attached to the built-in USB 2 hub on the CM4, as well as the USB 3 hub on the Turing Pi's VL805 chip. And when I plug in this little UASP flash drive, I should see it when I LSUSB again, right there. And to make sure it's showing up as a USB 3 device, I can run lsusb-t, and now it shows me that the drive is listed as a mass storage device using the UAS driver, and it's running at 5,000 megabits, which means I should be able to get the best performance possible. And if I unplug it and plug it into one of the ports on the back, there it is. So I know all the USB 3.0 ports are working on node 4. There are still a couple firmware bugs Turing Pi is ironing out before the big release in a month or so. One time while working on this video, I even had to use the JTAG interface to flash an updated bootloader, but I'll spare you the details. I have big plans for the cluster now that I got it working in my rack, so thanks especially to MyElectronics for sending over this enclosure. The next step is communicating with the cluster, formatting the RAID array, and setting up cluster management software, so make sure you're subscribed to see it. Until next time, I'm Jeff Geerling. It looks more awkward than it feels. Then I can press the power switch, and the cluster starts booting up one node at a time. Except it's not booting up at all. Then I can press the power switch, and the cluster starts booting up one node at a time. And it's still not doing anything. And that's where we're going to have to cut because the firmware that I loaded on here actually doesn't let the power button work, but we won't say that in the video. All right.